Hello students, welcome to Sri Vardhaman Vidyalaya online education. Today we will see the part 2 of chapter 3, metals and non-metals. In this part we will discuss about the properties of a non-metal. So first, what is non-metal? Those elements which form negative ion by gaining electrons are called non-metals. For example, iodine, sulfur, oxygen, hydrogen, etc. The nonmetals are either solid or gaseous except bromine, which is a liquid. So, so what is nonmetal? So here the elements which will gain two electrons and it will form a negative ion. For example, oxygen, the atomic number of an oxygen is 8. So the electronic configuration is 2 and 6. So it need 2 electrons to fulfill the outermost orbit, that is 8. So it will gain 2 electrons from the other elements and it will form an oxygen negative ion, that is O minus 2 ion. So that's why the oxygen is called as a non-metal. Activity 3.5. So collect the sample of carbon, coal or graphite, sulfur, iodine. Carry out the activity 3.1 to 3.6 with these non-metals and record your observations. So we have already seen the activity 3.1 and 3.2, 3.3, 3.4, 3.5, 3.6 that will be carried on in metals. So the same activity will be carried on with these non-metals and you have to observe the observation. Now compile your observations regarding metals and non-metals in the table. So now this is the example of a non-metal. So that is a carbon, phosphorus, sulfur, this is diamond. So these are also a non-metals. So when we see the activity, we will see this one. That is, we have taken an elements such as a carbon, sulfur and iodine. So element carbon, symbol C. For sulfur it is S, for iodine it is I. Type of a surface, that is non-luster, it is also a non-luster, it is a luster. Hardness, it is hard, sulfur and iodine both are soft. Mandibility and ductility, so the non-metals will not show a mandibility as well as a ductility. Conductions, heat and electricity. Here carbon, sulfur and iodine does not conduct a heat except that is electricity, that is in graphite, that is allotropes of a carbon is a graphite, so it will conduct an electricity. The other sulfur and iodine will not conduct an electricity. Sonority, it will not shows a sonority, that is sonar, that is it will not produce any sound. So these are the properties of a non-metals. Now, on the basis of the observations recorded in the table, discuss the general physical properties of metals and nonmetals. You must have concluded that we cannot group elements according to their physical properties alone, as there are many exceptions. For example, all metal except mercury exist as solid at room temperature. So, you have seen that is an all the metals are always solid except one, that is mercury. You know that is mercury will be used in a thermometer. It is in the form of a liquid. So you can see the diagram of a mercury. This is the diagram of a mercury. So it will be in a form of a liquid. This is a bromine. That is bromine is also in a liquid, that is non-metal, and this is metal. Now, as in the activity 3.5, you have observed that metal have high melting point, but gallium and cesium have very low melting point. So you have seen in the activity 3.5, that is all the metal will have a high melting point except that is two metal, that is gallium and cesium, and this will have a low melting point, and when these two metals will be kept in your palm, it will melt. So this two metal will melt if you keep them on your palm. Now, iodine is a non-metal, but it is a luster. Means you know that it will shows a shining surface. Most often a non-metal is not it will not shows any shining surface, except that is an iodine will shows a shining signing surface, that is we are calling as a lustre. Carbon is a non-metal that exists in a different form. So each form is called as an allotrope. So allotrope is nothing but it will shows in a 2 or 3 physical form, different physical form of a carbon. For example, you can see that is an allotropes of an carbon is an diamond, graphite. So these are the allotropes of an carbon. So each form is called as an allotrope. So diamond is an allotrope of a carbon and it is an hardest to nature substance known and has very high melting point and boiling point. So you know that is an all the metals are not an a hard, it is an a soft, except that is an a diamond which is an allotrope form of an a carbon. Same thing, the another allotrope form of an a graphite. You know that is an a metal will conduct an electricity, but non-metal will not conduct an electricity except that is an a graphite. Another allotropes of an carbon is an conduct of electricity, that is an graphite. Alkaline metal like lithium, sodium, potassium are so soft that they can be cut with a knife. So they have a low density and low melting point. So these are the exception of an metals and non-metals. Now we can discuss the physical properties of an non-metals. Mendability and ductility. You know what is mendability and ductility. Non-metals are either mendable or not ductile. That is, they cannot be beaten into thin sheet or drawn into a wire. Brittleness. Non-metals are brittle in nature. For instance, surface sulfur is a brittle solid. If it is harmed, it break into pieces. Metallic lustre. Non-metal do not have lustre, that is shining surface. However, the diamond, graphite, the allotrope form of carbon and iodine have lustre even though they are non-metal. Next is a physical state. Most of the non-metals are soft. Only the diamond, an allotrope form of a carbon, is the hardest known substance. Electrical and thermal conductivity. The non-metals are generally poor conductor of heat and electricity. So the graphite and an allotrope of a carbon is a good conductor of electricity. Here the spelling mistake of thermal, that is THERMAL. Melting point and boiling point. The non-metals generally have high melting and boiling point, but the non-metal that are solid have comparatively higher boiling point. For example, B is for boron, Si is silicon, C is a carbon, etc. So these are the physical properties of a non-metal. Next, the activity 3.8. Take a magnesium ribbon and some sulfur powder. Burn the magnesium ribbon, collect the ash formed and dissolve them in water. Test the result solutions with both red and blue litmus paper. Is the product formed on burning magnesium is acid or base? Now, burn the sulfur powder. Place a test tube over the burning sulfur to collect the fumes produced. Add some water to the above test tube and shake. Test the solution with a blue and red litmus paper. Is the product formed on burning sulfur is acidic or basic? And can you write the equation for this reaction? So in the above activity, we are taking two. One is a metal, that is a magnesium ribbon, and second one is a non-metal, that is a sulfur. Both we are burning. So, and we are collecting the ash from the magnesium, and from the sulfur we are collecting the fumes, and we are dissolving in the water. Just we have to test with both blue litmus paper and red litmus paper. So observation. This shows that the sulfur on heating produces sulfur dioxide, which turns blue litmus paper to the red due to acidic in nature. So on burning sulfur, we are getting a sulfur dioxide. So when we test this sulfur dioxide with a blue litmus paper, it will be turned into a red. So you know that is blue when converted into red, so it will become an acidic. Same thing, magnesium oxide is formed on burning magnesium. So the magnesium oxide turns red litmus paper to blue as it is a basic in nature. So the equation is Mg plus O2 gives MgO. So to balance these equations, we have written 2Mg plus O2 gives 2MgO, and sulfur S plus O2 gives SO2. So these are the two equations for this one. Next, conclusion. Most nonmetals produce acetic oxide which dissolve in water. On the other hand, the most metal gives rise to an basic oxide. So the non-metal will produce an acidic oxide when it will dissolve in the water, and the metal will produce an basic oxide when it will be dissolved in the water. Next, the chemical properties of a metal. Collect the sample of the following metal: aluminum, copper, iron, lead, magnesium, zinc and sodium. What happens when the metals are burnt in air? So, you have seen in the activity 3.8 that the magnesium burn in air with a dazzling white flame. Do all the metals react in the same manner? So, let us check by performing the following activity. So, activity 3.9. Hold any of the sample taken above with a pair of tongue and try burning over in a flame. Repeat with another metal sample. Collect the product if formed. Let the product and the metal surface cool down. Which metal burns easily? What flame color did you observe when the metal burnt? And how does the metal surface appear after burning? Arrange the metal in the decreasing order of their reactivity towards the oxygen. Are the products soluble in the water? So, in this activity, we are taking a sample of an aluminum, copper, iron, lead, magnesium, zinc, and sodium, and we are burning this in the presence of oxygen. So you have to see that which flame it will be formed and which color will be formed after burning, and arrange with a decreasing order of reactivity towards the oxygen, and is the product is soluble in the water. So that we will see in the table column. So observations: burns a metal with a pair of tongs to record the following observations. So metal Cu, that is copper. So the color of a flame is greenish blue. The color of burnt metal is black, and solubility it is insoluble. Same thing Fe, that is an ferrous or iron, no color flame and reddish color when it burnt the metal and insoluble in water. Sodium, the color of flame is yellow. The color of burnt metal is white and it is soluble in water. Magnesium, the Mg, it is white color flame. Burnt metal is also white, soluble in water. Calcium, brick red color. The color of burnt metal is white, partially soluble. Zinc, Zn, no color, white and insoluble. Aluminum, it is also white flame, white color of a burnt metal and insoluble in water. So these are the metals along with the color of the flame and the color of a burnt metal, and it is soluble in the water. So conclusion: sodium reacts vigorously with an oxygen. So it even catches fire if it left open in the air. Magnesium and calcium react less quickly with the oxygen. Ferrous, aluminum and zinc react slowly with oxygen. Copper did not burn but form a black coating of CuO. So the reactivity of a metal towards the oxygen in the decreasing order is: sodium will be highly reactive, then it is magnesium, aluminum, zinc, ferrous, lead and copper. So this will be the decreasing order of an reactivity. So the most reactive with the oxygen is an sodium. Thank you. Hope you all are understood. We will meet in the next session of this chapter, and we will discuss about the chemical properties of metals.